Hello, this is Meghla and I am going to start today with algebra. Part 1 is linear equation and the part 2 is going to be algebraic equation. Algebra. So first let me explain the terms, variables, terms, coefficient, expression, equation which is going to be used in algebra. Here the variables is nothing but this x, y, z, that is the value for the unknown we are giving. We are just giving names for the unknown values. Terms. Terms is nothing but when you say 2x plus 3y, whenever the values are separated by plus or minus or anything, then those values are called as terms. So 2x is one term and 3y is another term. Coefficient, the number before the variable, that is when you say 2x, 2 is a coefficient of x, or 3y, 3 is a coefficient of y. Similarly, expression. Expression is nothing but 2x plus 3y. When we write it, that is called expression, where you have the terms and this arithmetic operations is there, and it is not equated to anything, so therefore we call this as an expression. But when you equate this to something, then that becomes the equation. That is what is here. Next, algebraic expression. Here you can see what I explained there, like 3x plus 4y plus 8 is an expression, or you can call this as a polynomial. And here the variables are nothing but this x and y, and you know this 8 you have without this variable, and that cannot be changed at any cost, because here the variable meaning some value is there. So 4 into some value. If I say x, y equal to 2, therefore 4 into 2 is 8. Whereas 8 here you cannot change, that's why we call that as a constant, and here the coefficient of x along with variables, whatever you have, is called coefficients. Next, translating equations. Most of the time we may have to translate this English sentences. We have to form and convert that into equations. So we just see the sum of the 3 times a number and 8 is 36. So when the sum, that means addition of 3 times a number. So assuming the number is r, 3 times of that is nothing but 3r and 8. So we're going to add this 3r plus 8, and that is, whenever is comes, that is nothing but equal to. So equal to 36. Similarly, a number decreased by 2. So I am taking this number as n. Decreased by 2 is nothing but n minus 2. This is equal to 3. The sum of 8 and a number is 12. So sum is nothing but plus. Which two we are going to add? 8 and a number. Number is x. So 8 plus x is equal to 12. 2 less than a number is 4. So a number you are going to consider as y. 2 less than that, nothing but y minus 2, which is equal to 4. 9 is equal to number divided by 4. So 9 equal to, this is again you are going to replace by equal to, and taking the number as t divided by 4. So t divided by 4. Next, linear equation. So we are going to see this linear equation. Linear equation also is called as a simple equation. So here the mathematical equation is an expression containing at least one variable, that is an unknown values, and the equal sign with a mathematical expression on each side of it. An equation can be as simple as x equal to 0, or it can be complicated as 4 into 3y to the power 99 plus 76 equal to 42 divided by 3x. Or it can be anything else also, little harder than this also. Simple equation with one variable. An equation containing but one unknown quantity, and that quantity only in the first degree. So the degree meaning is, in any equation, the power we are going to see. When you say linear equation, you can see the power is only 1. You don't have square terms here. So when you go for the quadratic equation, you have the powers as 2. The maximum power of any variable will be 2 there. So we call that as a quadratic equation. So means similarly, when you go for cubic equation, you will have the maximum power as 3. So that is what is degree. So for any simple equation, we will have a degree of 1 only. So 2x plus 8, when you say there's one variable and one small equation, therefore this is called simple equation with one variable, where you can easily find out x equal to 4. Simple equation with two variables. When you have two variables, then we need two equations. So that is what is mentioned here. So when you have two variables, 2x plus 3y, that now we are going to use two variables x and y, that is equal to 8, or the other equation is 5x plus 4y equal to 13. So when you have two equations, you can solve it, provided there are some conditions applying. So you should have different equations, that we are going to see that later also. So it cannot be same. Simple equation with three variables. So three variables you can see here, we have x, y, z, three variables. When you have three variables, we need three equations. So this is one thing, and I just want to say one more thing is, sometimes the simple equation with two variables, when you have, there are some special conditions where you can have one single equation with two variables and you can solve the problems. That's called special equation. Similarly, here also the three variables, you can have two equations and you can solve, right? That is called special equation. Okay, that we are now going to deal now. We'll see that later. Types of solutions. So the different solutions which you're going to see here is unique solution, no solution, and infinitely many solutions. So any variables, like when you have going to solve, we'll consider for this linear equation with two variables. So when you try to solve that, you might get these three different solutions. So here we're going to see unique solution. When you say unique solution, it's only when it is consistent and the number of variables is equal to the number of equations. So here you can see that 2x plus y equal to 15 and 3y minus y equal to 5. We call this as a unique solution because when you solve for this, you will be getting the value of x and y, a single value of x and y. Because these two these two equations are different equations. Again, I'm stressing on this different equations, we'll see that later. A system has no solution if the equation is inconsistent, there are no contradictory. So when I say 2x plus 3y equal to 10 and 2x plus 3y equal to 12, so you can see that you have this left hand side both same, but the right hand side is not same. So when you try to solve this, you can see that you will be cancelling this left hand side, will be 0, whereas the right hand side is going to be 2. So in that way, you can say that it is not consistent. So therefore, you cannot get the solution. And similarly for the infinitely many solutions, when you consider it is consistent, the number of variables is more than the number of equations. I'll explain what is that. So when you have 2x plus 3y equal to 10 and 4x plus 6y is equal to 20, will you get any unique answer for this? Not possible. Why? Because the 2x plus 3y equal to 10 is, when you multiply that equation into 2, you are getting the second equation. So any equation when you have, you can still, like ratio, you can keep multiplying that into any value, that the equation is not going to change. So 2x plus 3y equal to 10 is same as 4x plus 6y is equal to 20. So that means you have a single equation, two variable, obviously you're going to get infinite solution. Let me explain this. What is exactly this is? So when I say linear equation with two variables, it's nothing but the line equation. Linear, it's a line. So line equation. So you're going to get lines for all this, whatever the equations you're given. When we consider the first one, 2x plus y equal to 15 and this one, it's in case if you write this in the form of y equal to mx plus c and find the slope of this line and try to find the slope of this line again. In that case, you can see that the slopes are not same. As they are different equations, the slopes are not same. That means there are two lines, they are not having the same inclination with respect to the x-axis. Therefore, they will be definitely meeting at one particular point. They will intersect each other at one particular point. So that point is what is a value which you have to find out, that x and y value result. Similarly, when you go to the second one, you can see that the slope, when you try to find, after writing this as y equal to mx plus c, when you find the slope of these two lines, they both are going to be equal, only the constant terms are different. So slope will be same. And when it says slope is same, that means inclination with respect to x-axis are same for both the lines. It may be anywhere, but the lines are having the same inclination. That means the two lines are parallel to each other. When the two lines are parallel to each other, they'll never meet. Because they never meet, you will not have any solution. The third one is you have a single equation. As I told you, there are two variables and single equation. That means it's a line. Maybe you can say one line or two lines, one above the other. So the point of intersection you can see everywhere. Any point you can take it as your solution. Therefore, we have infinite solutions. You can explain this in the other way also. The other way is, let us consider the two equations here. a1x plus b1y equal to c1, a2x plus b2y equal to c2. So these are the two equations you have. a1, b1 or nothing but or a2, b2 are the coefficients of x and y of these two equations. c1 and c2 are the constants. So when you take this, whatever the equation are given, and if you just take the coefficients or the constant terms, let us take if a1 by a2 and b1 by b2, c1 by c2, if you write, if a1 by a2 is not equal to b1 by b2 and it's not equal to c1 by c2, that means it's a different equation which I was mentioning earlier. So these equations are different, therefore you will definitely have unique solution. When a1 by a2 is not equal to b1 by b2, but it is equal to c1 by c2, in that case, you can see that there is no solution for this, as the left hand side will get cancelled and the right hand side will not get cancelled. And the third one is, if a1 by a2 is equal to b1 by b2, which is equal to c1 by c2, that means it is one and the same. So you are now going to have unique solution, but you will have infinite solutions. Next, let's start with the problems. So first we are going to start with the linear equation with one variable. Solve for x. So you have this equation. You can see that there is only one variable available here and there is one equation. So easily you can solve it. Just bring this 7 inside. So it's going to be 4x, and bring the 7 inside. Then it's going to be like minus 14. Minus x into minus x is plus 7x plus equal to 3x plus 2. So solve for this. You are going to get x is equal to 2. Next, solve for z. So here you have some kind of a values in the denominator. So it's again the simple problem, but slightly different, where you see something in the denominator. So first thing what you can do is you can remove this. As I said, the equations you can multiply into any value, it still is now going to change. So what you'll do is you'll just take the LCM of 3, 4 and 6. So LCM of 3, 4 and 6 is nothing but 12. So multiply both the equations, both the sides into 12. So when you multiply both the sides into 12, you can see that this 3 is getting cancelled. Here also it will get cancelled. Here also it will get cancelled. And finally you will not have anything in the denominator. And you just solve for this and you will get z is equal to minus 7 by 2. Next, linear equations with two variables. Solve the system of equations. X plus y equal to 7 and 3x minus 2y equal to 11. So you have now two variables. So how to solve this? There are different ways to solve. So let us start with the simple method first. So you have this x plus y equal to 7. So what we do here is, first step, we'll try to either find the x value or y value, and that value will replace here and try to find the other value. So let us consider now y value in the first one. So y equal to nothing, to bring this x to the other side. So y equal to 7 minus x. So y in terms of x we are taking it here. And this particular value of y you substitute here. So in that, when you substitute, 3x is equal to 3x minus 2 into y value 7 minus x equal to 11. So in that way you can see that this again becomes one equation with one variable. So you can solve for x again. So when you solve for x, you are going to get x is equal to 5. And substitute this 5 in this one, x plus y equal to 7. Or you can substitute here also. There is nothing wrong in that, but we will take this one because this is very simple. So x plus y equal to 7. When you know that x is equal to 5, y should be 2. That's the answer. Solve the system of equation 2x minus 3y equal to 1 and 3x minus 4y equal to 1. So here when you solve, the given equations are this, and what we do is the same as like the previous one. We are going to take the x value now. So when you take the other things to the next side, so you have 2x is equal to, you bring this 3y to the other side, so 1 plus 3y, and bring this 2 also to the other side, so x is equal to half of 1 plus 3y. And substitute this x value in this equation. So 3 into x is equal to half of 1 plus 3y minus 4y equal to 1. So when you solve for this, again it's going to be, you just bring it inside, so it's going to be 3 by 2. And this you bring it inside here, so it's going to be 3 by 2 into 3y is nothing but 9 by 2y minus 4y equal to 1. And then again when you solve for this, you bring this 3y to the other side, so 9y minus 8y by 2 is equal to 1 minus 3 by 2y. And from that you can find out that y is equal to minus 1. Substituting the value of y in the equation, you have this 2x minus 3, the first equation you are taking it. So you have found out y equal to minus 1. So you just substitute here 2x into minus 3 and y value is minus 1, which is nothing but now you are going to get this as 2x, okay, this equal to 1, that's mentioned here. So therefore you are going to get this as 2x plus 3y equal to 1, and from that you can find x is equal to minus 1. Therefore the two answers are x is equal to minus 1 and y equal to minus 1. Linear equations with two variables. Word problem again. Next problem. If twice the age of the son is added to age of father, the sum is 56. If twice the age of the father is added to the age of son, the sum is 82. Find the age of father and son. So now in this one with the word problem, you're going to see this now, because here mostly you will be getting problems of this kind where you have to convert and write in the form of algebraic equation. So here we will take this. Let us consider first